Hi everyone, welcome back. So today I will explain you how to build a linear model in machine learning. So in the simple linear model which handles the simple linear regression where you have the equation like y is equals to mx plus c, and this is where y is your dependent and x is the independent. Okay, now initially if I take consider the first step includes extract data. After that I will go to exploratory data analysis. I have to explain what the data contains. EDA. And the third step, after explanatory data, explaining the data content, I will build then feature e- extraction. Fourth step will be me model building. After building the model, I have to predict, means testing. And final step, visualize the results. So this is what the steps that comes under simple linear regression. In the extract data, what I will do, I will import the pandas package. I will read the data from CSV file or Excel file. In the explanatory data analysis, I will get the information about the data of the CSV file, whether it contains the null values or not, and information about each column and its respective data types. After that, I will do feature extraction, which comes where I will take the x and y, which is nothing but independent and dependent variables. I will separate those features. In the model building, after extracting, I will build a model based on the features that I have. Say, if I have the 100% data, out of that, I will give 70% of the data to the training and 30% of the data to the testing. After building a model, I have to check whether the model is exactly fitted or not, or performing well or not. For that, after building a model, I have to predict. I will do that step here. After predicting, I have to visualize the data. We are between the raw data and final results. Means after predicting what is the expected output, what was the actual output. That the step that I will do here. So let's do this in the next video. I will explain each and everything. Hi everyone. So in the last video I have explained the what are the steps to be carried. So let's start with the extract data code. I will import pandas as pd, and after that I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in the pandas, I will import the data. So in I will take data is equals to pd dot read underscore csv. Here I will pass the value where I am ready with this. Control C and paste it here. Make sure that your path is within the double slash, which considered as the escape character. So it will consider the first slash. Let's check whether it is data read or not. Data dot head. If I run this, select the kernel, so it will be going to execute, and I will get the first five rows. Good. So I am having the years of experience and salary, and I will consider the salary as my dependent variable. Okay. In the exploratory data analysis, I will check whether it contains any null values or not. Data dot is null dot sum. So there is no null values, and I will get information about the data frame information info. Good. So it is both are in the float type. Well and good. If it is an object, then it should be the error because it contains null values. Describe. I will check the information about everything. So I have the count, median, standard deviation, mean value, and 25% of total years of experience, 50 and 75, and maximum value. So there is no issues because no null values are there. Now I will go for the feature extraction. So for feature extraction, I will take x and y. In the data.ilog, I will take -1 means except the final one. I will consider everything, or else you can consider like this also. Copy this years of experience and give data within the bracket double quotes column name. You can do that also. Data dot ilog of column comma -1, which means the last column, or else I can write anything is okay. Data, anything can be work. So X will store the years of experience, Y will store salary. Let's check what will happen. First run this, executed, code, print X. Well and good. So years of experience I got. Say next one is print Y. This is my salary. Years of experience, and this is my salary. Now I will the build a model. In the build a model, the step one comes split. Step one 4.1 split data. From to split the data, I will take from sklearn dot model selection import train test split. So x train, y train, x test and y test will come from this method. Means this method will return four values. Those are x train, x test, y train, y test. and here I will pass x and y, which takes only 70% of the data. Test size 0.3 with random state equals to 42 or any number. You can also give any number. Print. Let's check the size shape of the X train shape. X underscore train dot shape. In the same way for the Y train also. For the test, Y test, X test. This will be Y test. Let's run. So here if you see X train and Y train, X train, Y train, I have split it. Next step will be 4.2 train the model. To train the model from sklearn dot linear model import linear regression. Now model is equals to, I will take the reference of the object model. Now I will fit model dot fit x train comma y train. Here I am training the 70% of data. How? I have given entire data set where I am saying that I will keep 30% of the data for the testing and remaining will be 70%. So those 70% is my training data, which is fitted to this linear model. Executed, done. After that, I have to predict the model. What is the accuracy? So testing accuracy is equals to model dot score x test comma y test. Print test accuracy, testing accuracy. Oh, nice. So model is predicting around 94%. 94%. We can find the some more metrics, evaluation metrics. How can you do that? From sklearn dot metrics import mean absolute error, mean squared error, and I will take import numpy as well for the simple mathematical calculations. NumPy as alias numpy np. So I will take train accuracy. You can also find the training accuracy as well. Train accuracy equals to model dot score x train comma y train. Print train accuracy. I think we can also make this as testing accuracy. This is my training accuracy, and I will add mean absolute error (MEAE) variable, and here I will take mean absolute error for x y test. Sorry, for the y test, comma model dot predict x test. So I'm comparing with the y test with the predicting values. So this is my raw, this is my predicted values. In the same way, print MAE. I will copy this step. Mean squared error MSC. Mean mean squared error MSC. Mean absolute error MEAE. And final one, root mean square error. Root mean square error is nothing but the square root of mean squared error. So from np dot sqrt, I will pass MSC directory. So I will print root mean squared error as RMSC. Got it? So I will run this. Let's see. Nice. So training accuracy is my 95% and testing accuracy is also a 94%. So it is good. Now I will visualize the results. To visualize the results, I have to plot. How? I will import the package, import matplot lib dot pipe plot alias as plt. I will plot plt dot plot x test comma y test. This is my raw, means raw data. So this is my test data. So I will label it label equals to testing data, or else I can say tested data, test data. I will plot in the same window with x test and model dot predict x test, which is nothing but y, y prediction. I will label it with predict values. This will predict it. So as I have given the label, I have to display it with legend function, and I will show the plot dot show. If I run this, oh, this is how the results came. So predicted value and testing test data. So it is uneven because the salary is fluctuation. So I will. How can I do that? Take this as scatter. Okay, instead of plot. If I run this again, cool. So I found the best fit tag, and I think I have to arrange set the color. C is equals to color is equals to red, and here also color is equals to red and green. If I run this, this is my best fit rate for the prediction predicted values. I can add the titles plt dot title simple linear regression plt dot x label salaries plt dot y label years of experience. Okay, so in the x-axis I have the okay years of salary. Okay, it should be swap. I will simply y do this as y label. This will be x label. That's it. Done. Okay, and this is how we can build an simple linear regression. In the recap, first I have extract what is simple linear. Linear is nothing but y equals to mx plus c, and this is the simple one equation, simple linear equation with one independent variable. Simple linear regression with, which has only one independent variable, okay, and one dependent variable only. That's it. And to build this model, first I have to extract the data. I have extracted the data. After extracting data, I have explained the data, whether it contains null values or not. If not, then what is the data information and describe the data. I have described. After that, I have done the feature extraction. I have saved the independent variable in X and dependent variable as Y, and I have executed and checked whether it is okay or not. And after that, I have built a model. First, I have split the data in two parts. 30% of the data will go for the training set and 30% of the data to the testing set. And I have taken the linear regression for train the model for with the training set. So this is my 70% of data is being trained to this linear model. After that, I have predicted with the testing data, which is the 30% of data, which gives me 94%. After that, evaluation metrics for a training set and mean absolute error, squared error, and root mean square. This is the values, and this is my visualizing data. This is my data that I have got. So this is my best fit train. So it gives me the linearity. How much fit has been done as per the testing data. This is my simple linear regression. Any doubts? Any explanation you need? Let me know. Thank you. Hi everyone. In the last video, I have explained you how to build a model for a simple linear regression, and today we'll talk about the multilinear regression. So, what is multilinear regression? Say there is an equation, line equation y equals to mx plus c. Okay, this is the line equation y is equals to mx plus c. And here y is dependent variable and x is my independent variable, and this is nothing but simple linear regression. And in the multilinear regression, I have more than one independent variable, like y equals to m1 plus m1 into x1 plus m2 into x2 plus and so on plus c. So this is my multilinear regression. This is what multilinear regression. And one dependent variable and more than one independent variables. This is my multilinear regression. Okay, so the first step, I will extract the data. These are the four steps: extract data. Next, I will get the details of the data. I have to explain the data. EDA is nothing but explanatory data analysis, where I will check any null values are there or not. The third step, feature extraction. The fourth step, model building. The fifth step, evaluation. These are the steps that comes under the multilinear regression. And one more new step comes within the feature extraction is scaling. Feature scaling. Okay, this is how these are the steps that comes under multilinear regression. And in the next video, I will explain how to build a model and Python code using sklet. For the building in multilinear regression, I will use module name called sklet. Sklet. So this is the module. Let's talk about the next video. That's it from me. Thank you. Hi everyone, welcome back. So today we'll continue with the multilinear regression, and in this video I will explain how to build and machine a multilinear regression model. And the first step is my extract data. For extracting data, I will import pandas as PD. This pandas will read the data from the CSV file data variable, which stores the data read from the CSV file pd dot read csv. Within double quotes, I will paste my file location. In the path, you have to give double slash to consider the slash data dot head, which returns the first 5 rows. Python environment, kernel detected, conda environment, and now I am having the multiple independent variables. What are those? Let's see what we will get. It is still connecting. Once it is connected, it will go to execute. So these are the column names: R&D spend, administration, marketing spend, state, and profit. Okay. So I will check first what are the null values present or not. I will check whether the any null values is there or not, missing values. And here profit is my dependent. Sorry, profit is my y, and independent will be state, marketing, speed, administration, R&D spend. And we have to consider whether it is considered as the independent or not. For that, I will explain you in the EDA. Okay. So in the EDA, explanatory data analysis, I will initially check whether it contains null values or not. Is null dot sum. If I run this, okay, there are no null values. Let's get the information. Okay, float object. So I have to consider change it to float. In the initial simple linear regression, what I told is if there is an object, then you have to convert into integer or float type. Data dot describe. Okay, so these are the description of the data frame. Okay, now in the next step I will use the feature extraction, but before that I have to change this object to float or integer type. How can I do that? For that, from scalar dot pre-processing import label encoder. Now take LE as reference for label encoder. Now label encoder will change the this categorical variable column as the integers. So I will take as state, or we can use -2 also, no issues. Data of is equals to le dot fit transform data of state. So if I check the data dot head, did you see? Earlier it was the string, and now it converted to integers. One. What does it mean? Means this one is mapped to one v- value, that is Florida. Florida considered as one, and two is mapped with New York, and California with 0. So it is mapping with the integers. So finally we have converted it. Conversion done. Now before cutting the feature extraction, means x and y, I will check whether the data is exactly correlated with dependent variable or not. For that, I will import cborn as SNS dot pair plot for data. So it will give me the linearity or not. If it is linear, then it is considerable, else not considered. If you want to see the correlation, if it is near to one value, then we can consider data dot correlation and not equals to. Okay, I'll explain. So if you see this graph, it will give me the linearity graph. So profit and R&D spent is linearity because it is something in the straight line, looks like in the straight line. And administration is something is scattered, and the state is linearity, but it is something exactly not, which is in the categorical 0 1 2, and in the marketing strategy it looks like something linear. So if I consider this and this, the model will be good, and I should not consider profit and profit because profit and profit is always one. So let's see the correlation. Okay, so this, if this is my y, and my independent variable will be R&D because it is nearest to 1, 0.9, and 0.2. I think we can also consider, but model will be not good. Okay, we can consider, and which is 0.1. It is very bad, which is not exactly dependent on this y. So I will consider the x as data dot index location starting from all, including all rows for except minus 2, because I will not consider this profit, I will not consider this state, but rest of everything I will consider. That's why minus 2. So minus 2 means excluding state, I will consider everything from this side. Okay, I got it. Now in the dependent variable data dot index location, in, consider all rows and only the last column dot values values. If I check the values for x, print x. Yes, I got it. Print y. Okay, so now I have to scale the features. For the scaling the from scalar dot preprocessing import standard scalar. I will take as the reference standard scalar, and I will apply this to this x. So before that, I have to give train test split. I have to split the data from sk learn dot model selection import train test split x train x test y train y test equals to train test split for x and y with the test size. I will use 30% of the data as test set. So remaining 70% will be my training set. Done. Now I will use xtrain replace with the standard xtrain dot fit transform x tree. In the same way for the test also, sa dot transform x test. Okay, so now in the model building, I will take linear regression from sklearn dot linear model import linear regression, and model will be linear regression. Now I will fit this model to the training set. Model dot fit x train comma y train. Okay, good. So till now what I have done is I have checked the correlation with the y, and if it is nearly to the one, the profit is exactly dependent on the independent variables. And in the feature scaling, I have first splitted the data as X train and Y train, X test and Y test. And this train test split will divide the data set into two types, two halves, where it consider as half part will be for the training, half part will be for the testing. And those values will be stored in these variables. And I will fit the standard. I will do the standards scaling for extend and extest to handle the data frame of the training and test set. And in the model building, I will use linear regression to fit the model, which having the multiple features and one dependent feature. So here I am having the multi-linear regression model. It has been initialized. So next step I will do the evaluation. So for the evaluation, I will to consider the metrics from sklearn dot metrics import R2 score, mean absolute error, squared error, and some mathematical operations for that numpy as np. So my test accuracy or score equals to model dot score x test comma y test, train score equals to model dot score x train comma y train, print testing score test score, print trained score train score variable. Now mean absolute error, mean absolute error for y predict. So I will consider y pred equals to model dot prediction for x test underscore test, and I will check the mean absolute error between y test and y print. So in this y print, I will having the predicted values for the x test. I will complete now. I will take the absolute error between the y original values and predicted values. In the same way for MSc, mean square error mean squared error. I will get y test, comma y print. Root mean square RMSC equals to np dot sqrt for MSC. Print MAE mean absolute error value will be MAE. Print. Okay, so this will be MAE. Print MSC will be my MSC. Print RMSC will be RMSC. If I want to see the what is the R2 score also, y test, comma y print R2s. Print R2 score will be my R2s. If I run this, I got this. This is a testing score of 0.88, training score 0.97, and absolute error, squared error, root mean square, the R2 score. So if I want to know what is the coefficient also, we can also find. So coefficient means C. In the line equation y equals to mx plus c, I will find C. What is the intercept? So for that, intercept or coefficient, COEF. Intercept or coefficient. Okay. For that, model dot coefficient, and I will have the slope also. Slope equals to model dot intercept. Print inter CPT or constant will be my COF. Print slope values, slope values, which will return array of integers. Why? Because in the multilinear regression I am having the multiple independent variables. For each independent variable I will having the individual slopes. Okay. Slope values are slope. If I run this, this is my const. Okay, okay, sorry. This is these are this is the intercept, and coefficients are slopes. This is what I have. Okay. So just a small recap once again. I'm having the multilinear regression. Y equals to mx plus c is my simple linear, and y equals to m1 x1 m2 x2 plus c. So this is the my multiple linear regression where m1 m2 are the slopes and x1 x2 are the independent variables. And I have done the extraction of the data, and checked whether it is null values or not, and got the information about the data frame. In the data frame, I am having the object, so I have consider changed it to the integers by mapping the numbers using a label encoder, and feature extraction. I have plotted the pair plot for check the linearity and the correlation. For correlation, I have used the heat map and annotate with the value, annotate for seeing the correlation values. So I found that in the for the profit, the R&D, administration, and marketing speed are nearly to one. So I have considered these three only. So I have taken X and Y variables for independent and dependent. And in the feature scaling, I have first step is my to uh, split the data as training set and test set, and using standard scalar on independent variables. And for the model building, I have taken the linear regression from linear model, and I have applied the evaluation metrics. And now this is my steps to find the what is the slope of the multiple lines, multiple features. So this is my slope, and this is my intercept. This is how you can find the values. That's it from me. Thank you. If you have any doubts, pin me in the comments.